plug it in. So if I give you the intensity, we're going to plug that in for I. And B, if you want to know, this unknown is the decibel. And this unknown is the sound intensity. Okay. So first I'm going to just show you how you would evaluate this because we could do this in our heads, just because they're all powers of 10. And then what I'm going to do is show you how you could do this on your calculator. So I'm going to rewrite the formula. I'm going to do the decibels equals 10 times the log of 10 squared over 10 to the negative 12. Okay, so this is how I'm going to do this in my head, or by hand. Do you see these are both bases of 10? So we can subtract the exponents. What's 2 minus a negative 12? 14. So this is 10 times log of 10 to the 14th. And then this is common log. So what, I'm going to ignore that 10 right there. What the common log says is if I have a base of 10, what exponent is 10 to the 14th? So what would be the answer to that? 14, because it's written in that form. So log of 10 to the 14th is 14. 10 times 14 equals 140 decibels. Okay, so let's say you were confused, you didn't know how to do that, because there might be other logarithms in your book that aren't written as powers of 10. Because I had this, you could have also just typed this into your calculator. 10 times the log of 10 squared divided by 10 to the negative 12. Okay, does that make sense? All right, let's go the other way, because the other way is probably a little trickier. So for the second part of my example, we're going to find the sound intensity of a noise that is 85 decibels. So once again, I'll just rewrite my formula down here. So this time, I know the decibel value, so I'm going to put that in for beta. We're going to work some more on solving with these things on Monday. On Monday we're going to work with solving both exponential and log equations, but this is a pretty basic one, and we've talked about the decibel scale, so I think we should do it today. Let's just first get rid of this 10, not get rid of. I want the log expression to be by itself. So we can divide by 10, following. So now I have 8.5 equals log of I over 10 to the negative 12. You have done things like this already, except you might not be recognizing it because there's a lot of different variables than y and x. But all we're going to do here is we're going to rewrite this in exponential form. So remember, let's refresh our memories. In general, if this is a logarithm, its exponential form is the base. Do you remember where we get the exponent from? On the other side of the equals. Okay, those are equivalent statements. Let's do it with this one. What's the base of this log if it's not written? And then the exponent is on the other side. So 10 to the 8.5 equals this whole thing, because that's what's inside the log. So finally, what would I do? Multiply both sides by 10 to the negative 12. Okay. So if we were writing this as a power of 10, what would this be? Add the exponents, right? 10 to the negative 3.5, and the units are watts per square meter. Because it's not exact, you could also actually calculate it, but it's going to be 0.000316 if you're doing it that way. So it's pretty small, so I think we should just leave it as a power of 10. Okay?